How could we find the amount of wood needed to frame a poster made from a photo? In this lesson, you will learn how to compute an actual perimeter from a scale drawing by using ratios and proportions. Let's review. A proportion is an equation that relates two equal ratios. For example, the ratios 5/6 and 25/30 are equal, so this is a proportion. We can use a proportion to find the length of a missing side by cross-multiplying. Here is a pair of similar parallelograms. The sides QR and WX are corresponding sides, so the lengths 6 and 10 can be written in a ratio. The sides TQ and ZW are also corresponding sides, so their lengths can be written in a ratio as well. Notice that the shorter side is written in the numerator of each ratio. Now we cross-multiply. We find the product of the extremes, that is 6 times 15, and that will equal the product of the means, that is 10 times TQ. We simplify the multiplication and divide by 10 to solve for TQ, which has a length of 9. A common mistake is to mix up the order of one ratio in a proportion. Here is a pair of similar triangles. Sides 16 and 8 correspond, so we write them in a ratio. Sides 22 and 11 correspond, but if we write the ratio 11/22, we're placing the longer side in the numerator of the first ratio and in the denominator of the second ratio. That's like saying that 2 equals 1/2. Therefore, this proportion is false. So how do we find the ratio of perimeters from a scale factor? Here is a rectangle with a height of 3 and a base of 4. Its perimeter is found by adding up the 4 side lengths. We could also think of this as adding 2 groups of 4 plus 2 groups of 3 for a total perimeter of 14. Now let's double each side. That gives us a large rectangle with a height of 6 and a base of 8. We add to find its perimeter, which is like adding 2 groups of 8 plus 2 groups of 6 for a total perimeter of 28. Notice that the scale factor of the sides was 1 to 2, and the scale factor of the perimeters, 14 to 28, is also 1 to 2. Why does this happen? Think about wrapping rectangle QRST with the sides of rectangle ABCD. It would take 2 of each side of the small rectangle to wrap each side of the large rectangle. Watch how this looks. What this tells us is that the ratio of perimeters is the same as the ratio of sides in similar figures. Let's find the perimeter of triangle LMN, even though we only know one side. We start by writing a scale factor of the known sides. 18 to 24 is the same as 3 to 4. Notice that I'm putting the small one first. The ratio of perimeters then is also 3 to 4. Now we can find the perimeter of the large triangle because all 3 sides are given. That adds up to 70. Setting up a proportion, we put the scale factor 3/4 equal to the ratio of perimeters, small perimeter over large perimeter. We multiply the extremes to get 210, and we multiply the means to get 4 times the perimeter. When we solve, we find that the perimeter of the small triangle is 52.5. Now we can figure out how to frame our poster. Say that we have a 4 by 6 inch photo, and we'd like to make a poster that is 30 inches tall. We need to find a scale factor to start. The small to the large height is 4 to 30, or 2 to 15. The small perimeter is 2 groups of 6 plus 2 groups of 4, or 20 inches. We know that the ratio of perimeters is the same as the ratio of sides, so 2 to 15 is the ratio of small perimeter to large perimeter. We're using cross-multiplying again. 2 times p, the extremes, equals 15 times 20, the means, which is 300, and we can solve for P, which is 150 inches. That tells us we would need 150 inches of framing material to frame our poster. In this lesson, you have learned how to compute an actual perimeter from a scale drawing by using ratios and proportions.